Well, hopefully you've had a chance to at least look over the ones on the front. What do you notice about the lines on all the ones in the yes column? Yeah. So that's part of what's going on. We've got parallel lines. Over here, none of the lines are known to be parallel. Fact is, they all look like they're going to intersect at some point. And then, what type of angles are these angles? Corresponding angles. And what seems to be true about the measures and all of them on the yes column? Yeah, they're the same. Whereas over here, are the angles the same? No. So our conjecture might read something like this. Well, I'll take a volunteer. Does someone want to volunteer what they wrote? Yes.
Everything in the yes column has a pair of parallel lines and contains a pair of, what are those called? Corresponding angles?
And what about the corresponding angles?
The same angle?
Same measure.
Measure.
Okay. So I'm going to clean that up a little bit, and I'm going to make it into a conjecture. When
I forgot what a conjecture was.
it's an educated guess, basically, based on what we know. When there are two parallel lines, the corresponding angles will be congruent. Now, have we proved that that's true? Have we given anything other than some examples? No. What would I have to do to show that this was false? Find a counterexample, exactly right. And here's the deal. You'll never find a counterexample for that. There is none. But that's still not a proof. That is why this conjecture is the corresponding angles postulate. A postulate is a statement that we accept as true without any proof. Now, you say, well, what do you mean without any proof? Well, examples are not proof. I don't care how many examples you give, it's not proof. Now, it can lead you to believe something is true, but it doesn't prove that it's true. So, for example, I might tell you that, I believe that short people are mean, and I can give you a list of 10 short people that are all mean. Does that mean all short people are mean?
Why'd you look over here?
Because you were making a face. Okay, no. Right? But that might lead you to believe that. And that happens all the time to people. Right? There's a certain class of people, whatever they are. Short, tall, who knows. And they run into several that are a particular way, and they generalize. Sometimes the generalization is right. Sometimes it's wrong. Okay? When you generalize like that, you always have to be willing to accept, okay, I found one that's a counterexample. I can't believe that anymore. So, the corresponding angles postulate says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So in this diagram I've listed all 4 sets of corresponding angles, those are all going to be congruent to each other. So that allows us to do a problem like this. They ask us to solve this for x. Notice you have to be given that those lines are parallel. If you don't know those lines are parallel, we don't know the corresponding angles are congruent. They might be, they might not be. So I'll know that 2x minus 45 is equal to x plus 30. So x is 75. All right, let's look at this example. To do this example, you'll need the corresponding angles postulate, and then you'll need a bunch of stuff that you already know. Go ahead and just find all the lettered angles, but find all the angles. Find the measure of every angle in that picture. You've got 30 seconds. Go. And you're welcome to talk to someone near you. All right, let's see how you did. I always start with the easy ones. If this is 110, angle A's got to be 110. Who can tell me why I know that's true? Yeah.
Because they're vertical angles.
Yeah, and what do you know about vertical angles?
They're congruent.
Vertical angles are always congruent, absolutely. Then I can use my corresponding angles postulate to go, oh, this original 110 corresponds to x. It's got to be 110. Now there are two different ways I can find y. Two different ways. What's one way? Yes.
Vertical angles.
Yep. I know that the vertical angles are congruent. What's the other way? Yes.
Corresponding with A.
Yeah. It's corresponding with A, so the corresponding angles postulate says that those two are going to be the same. Those four angles are all the same. This is going to be true every time you've got two lines crossed by a transversal. You're going to have one set of four that are all the same. Now, how can I find the measure of angle Z? Let's see if I can get someone else to volunteer besides the three people who have already volunteered. Well, if some of you have it written down, Abby?
What? 110? But I don't know how to find it. It's because like
I understand. X plus C make a line.
X and Z.
Yes. What kind of angles are those? They have a name.
Oh, congruent.
No.
180. I mean, be straight. I mean, oh shoot.
This is sad.
180. Supplement. Yeah, supplementary.
So they make a line, so they are a linear
So like-
pair.
So 70.
So these two are a linear pair.
Does not start with an S.
Supplementary is how they're related.
Hey,
Hello.
Mr. Davis.
How's it going?
Good, this is for you. You might
Thanks.
want to open it. It's for teacher appreciation.
Oh, thank you so much.
Nuh-uh, it's for volleyball. That's just.
Oh gosh.
You have to go. It's a
I
teacher
have to go?
appreciation. You have to.
When is it?
I don't know.
Look at the court.
It doesn't say on the
Information
outside.
and
All you
the
need
card.
is in there.
Okay, thank you so much.
Well, you guys just got saved from.
Okay, so the type of angles they are is a linear pair. How they're related to each other is they're supplementary. Okay?
Girl, what you said 110.
You did say 110.
Lexi, you were like.
So if you take 180 minus 110,
Like you said all there was
and this is 70. Shh. So that means that this angle is 70. And by corresponding angles, both of these angles are 70. This always happens when you have two parallel lines that are crossed by a transversal. You're going to have one set of angles are one measure, the other set of angles are the other measure. Before we go on, don't turn the page just yet. What kind of angles are the y and the, pardon me, the original 110?
Interior alternating angles. Wait.
You know, try that again.
What?
Alternating interior angles.
Yeah, just alternate. We usually don't say alternating, but yes, I understood what you meant. Alternate interior angles. What do you notice about those?
They're the same.
They're the same. Oh, hey.
Oh.
And what do you notice about X and A? What kind of angles are they? Alternate exterior angles. Oh, those are the same. Are they all the same then? Well, what kind of angles are the Z and the original 110?
Supplementary.
Now, what type of angles are they? Not how are they related? What? Same side interior, thank you very much. They are same side interior angles. How are they related? They're supplementary to one another. Okay, I think that's really easy to remember because same side interior angles are supplementary, right? The one with all the S's is the one that's supplementary. All the other ones are congruent to each other. All right, so page 2. These are all theorems because we can prove that they're true based on what we already know. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Likewise with the alternate exterior angles, and the same side interior angles are supplementary. Now you may be asking, well, how is it that you can prove that that's true? Well, let's say if I wanted to prove that angle 2 is congruent to angle 6. Don't worry about writing any of this, just watch for just a second. Do I know that angle 2 is congruent to angle 8?
Yes.
Because they are
Vertical.
vertical angles. And because of the corresponding angles postulate, what do I know about angle 8 and angle 6?
They're the same.
They're congruent as well. And if 2 is congruent to 8 and 8 is congruent to 6, then 2's got to be congruent to 6. I just proved it. Okay, based on things that we already knew. That's why you have to do the corresponding angles postulate first, because it's the key to unlocking all the other ones. All right, so let's do some example problems. So here we're trying to find the measure of angle TUS. First things first, we need to check to make sure that the lines are given as parallel. If they're not, none of these things work. They're given as parallel, so that's fine. Then I need to look and see, well, what type of angles do I have? What type of angles are these two angles?
Same side interior.
Same side interior. So how are they related to each other?
They're supplementary.
They're supplementary. So 13x plus 23x.
Wait, how are they supplementary?
Makes a line.
No. It's not because it makes a line. They're same side interior angles. When you have same side interior angles that are made by parallel lines, they're always going to be supplementary.
Okay.
The other way to think about it is this. Let's look at these two angles. Is that acute or obtuse?
Acute.
Is this one acute or obtuse?
Acute.
Try again?
Oh, obtuse.
Yeah, that one's pretty clearly obtuse. So they're clearly not the same size, are they? But they're made by parallel lines. When you have angles that are made by parallel lines, they're either the same size or they're supplementary. Every single time. Okay?
Okay.
So this is equal to 180. So that'll be 36x is 180. Divide and we get that x is 5. So then the measure of angle TUS is 23 times 5 is 115 degrees. Just in general, I try whenever possible to make angles that look like they're obtuse have a measure greater than 90, and angles that are acute look like they're acute have a measure less than 90. Every now and then one will slip by me and it won't be. That doesn't mean the problem's wrong, it's just the diagram doesn't really match it particularly well. Okay? All right, let's take a look at this one. So, are the lines marked parallel?
Yes.
Yes. So we're good to go with the new stuff that we have learned. What type of angles are these? Alternate interior angles. What's the relationship between alternate interior angles when we have parallel lines? They're congruent to each other. So that means these two angles have the same measure. 2x plus 10 is equal to 3x minus 15. Subtracting 2x and adding 15 gives me x is 25. So then the measure of angle ABD is going to be 2 times 25 plus 10 is 60 degrees. Questions about that? All right. One more. For this problem, we want to solve for both x and y. And you have to be careful which direction you work. What do I mean by that? Well, what I mean is this. The theorems that we have all start off with if two parallel lines are crossed by a transversal. Every single one of them starts off the same way. So, don't do this, but if I ignored all this over here and just looked at those two angles, do I have a line that's crossing two parallel lines?
No.
No. So there's no relationship between these two angles. It's possible that they're related, but we have no evidence that there's any relationship. So you have to be careful about that kind of stuff. So instead, what we want to do, scribble. What if we look just down here? Is this line crossing two parallel lines?
Yes.
Yeah, it's actually crossing three, but that's okay, it can cross more. So there is a relationship between these two angles. What type of angles are these two angles?
Same side interior.
Same side interior. So what should be true about them? They're supplementary, exactly right. So 25x plus 4y plus 60 is 180. And I can help that along a little bit by subtracting 60 from both sides. And I get 25x plus 4y is 120. But now I've got a problem. Can I solve that? Why not? Yeah, there's two variables and how many equations? Just one. When you're solving things like that, you have to have the same number of variables as you have equations. I guess I should say it the other way around. You need at least the same number of equations as you have variables. You'll do more of this next year in Algebra 2. You'll do, last year you guys solved two variable, two equations, right? You either added the two equations together or you substituted. You'll learn how to do, what if you have three variables and three equations, or four? Have you guys already done that in Algebra 2?
Yeah.
Yeah. And have you used matrices yet or not yet? You have? Okay. So you'll get to that. We're not going to do beyond two equations, two variables in this class. So I can't solve that yet. Well, now I go up here and I go, okay, here is a transversal crossing two parallel lines. So that means there's a relationship between the 125 and the 25x plus 5y. What kind of angles are those two angles? Alternate exterior. When lines are parallel, what's true about the alternate exterior angles? Yeah, they are congruent. Okay, so their measures are equal. So that means 25x plus 5y is equal to 125. Well, I can't solve that equation either. There are several ways that you could do this. I will tell you that your book cooks these up so that they're really easy if you do one thing. I'm going to write this equation directly underneath this one, and hopefully you're going to see what I could do with these two equations that would make it really easy to solve.
Subtract.
Yeah, I could just subtract those two equations.
You put plus 4y. Wait. Oh.
I'm using the other equation.
That makes sense.
So when I subtract them, I just get y equals 5. And once I have what y is equal to, I can substitute that into, let's substitute it into the first equation. See, that's 25, so I'll subtract 25 from both sides. And I get 25x is 100, so x is 4. So x is 4 and y is 5. Yeah, any questions about that? All right. I think your assignment is in the book. Yes. Your assignment is in the book today. And you can go ahead and get started on that, because I think you still have some pretty good amount of time. Let's see, it's not quite 1:30. Yeah, so you have 14 minutes or so. That's enough to get a chunk done. Yes, ma'am.
Are we using the back of the?
No.
Okay.
Some years I do that if I have lots of time. Some years I don't. It just depends on my mood on that day.